Hello everyone, I'm Eugene Babichenko from the Remme team, and today I'm gonna tell you about some implementation details of the Remme protocol, give you the overview of the protocol, tell you about some use cases, and how the blockchain is related to our solution. As you may already know, the Remme protocol is the system for distributed management of X509 client certificates that are widely used in many scenarios to authenticate some counterparty. For example, if we are talking about web resources, the server authenticates its client with the help of a certificate and the associated private key. This scenario is pretty common in banking, in governance, and so on. All places where we need a high degree of security, and password is an unacceptable way to authenticate the user because it can be easily stolen with the help of social engineering, with malware, and so on. Those certificates are also widely used in machine-to-machine interactions. This is a very natural way to authenticate some machine to another. For example, some sensor is sending its data to a remote server, and to authenticate the server requests a client certificate from the sensor. Another use case is security tokens. Actually, it's pretty similar to the first one, except that private keys are stored on spatial hardware. Nowadays, those certificates are managed in a very centralized way. We have some central certification authority which signs all the certificates it issues, which manages the revocation of those certificates in case something is wrong with them. For example, if we want to revoke access from someone, or if the private key was lost, or in some other cases. To distribute workload from the central authority, they create intermediate authorities. First of all, they create additional costs, and on the other hand, they also need to be managed, to be controlled if they follow all the required rules. For example, that was the case with Symantec, and all the keys which were signed by the Semantic Root Authority are now untrusted, and the Semantic Root Authority is also untrusted. That was a big problem because all of the vendors needed several months to upgrade their software on all of client machines. All browsers needed to be updated, and it was a pretty major issue in the security war. In the security world for about 1 year ago. Those authorities also manage certificate revocation, and when the authority server which manages those revocation is inaccessible, that may become a very big security issue. What we do in Remme is actually solving all of the issues I mentioned before with decentralization. It eliminates the single point of failure. For example, if one server in a decentralized system is inaccessible, you just switch to another one, and that's all. No problem of single point of failure. Then we also work on distributed validation of users' data for creating a kind of distributed registration authority that will solve the problem of control over the system, because all nodes validate each other. And this system should have lower costs because there are not that much intermediaries. You just submit your request to one of the nodes in the system, and that's all. And now probably one of the most interesting parts, so why we use the blockchain. Not only because of hype around this technology. This is a good way to maintain the consistency and immutability in a distributed system. If the system is public, the blockchain is the perfect fit. And another property of the blockchain, which is very interesting, that it stores the log of all transactions in the system, and that is another way how we manage the security in the system, because such logs of certificates are very similar to the certificate transparency technology, which is being developed now. And this is the technology which is meant to provide logs of all actions about the certificates in a traditional centralized system. And we have such a feature just out of the box. So what we actually do is all about storing public keys of certificates on the blockchain, storing their validity times and their revocation statuses. And what we're working on now is creating the system for distributed verification of some user-related data. From the technical point of view, one of the most popular questions is why we use Sawtooth and why you use some framework at all. Why don't you write your blockchain from scratch? First of all, we want to deliver the solution for the actual problem, which is the certificate management. We prefer to write on top of some existing solution. That is why we use a framework. Why we use exactly Sawtooth is because that is one of frameworks which is suitable for public networks, which is performant enough for our needs. One of the most important parts that this framework is language agnostic, so we shouldn't stick to some platform-specific language, like we should have done if we used Ethereum. So, for example, we use Python and Rust to write all our stuff which is performing the cryptographic part of the application, and that brings us some more performance. It's actually easier because those tools have the infrastructure around them, and this infrastructure is better than around Ethereum specific languages, for example. The system has customizable consensus algorithm, so you can just plug the existing consensus algorithm out and insert your own in a pretty simple way. And this is very important for us because we want to scale, and because we want to scale, we have to develop something on our own, and we have to maintain the economical incentives for the members of our network, and this also requires some customization. First of all, we have the component which come with a framework. This is the validator component, which is the core of the system, which maintains all interactions with other nodes, the basic transaction validation, and it also maintains the data storage. We have our transaction processors, which are entities that actually do the business logic of the system, and we have our custom API, and this is not displayed on this picture, but the consensus algorithm is also plugged somewhere in there. And now I'm gonna tell you something about our network. In this picture we see a couple of nodes interconnected into a little network, and we see some client applications. Here we can easily see why the decentralized system may be better than a centralized one. If this node fails, we just switch to another node, and that's okay. Another node have the same data, the same logic, the same API. These nodes also replicate all the data, all the transaction history, all the certificates, statuses, and this redundancy makes our system very robust.